Hello, one and all present here. This is Amit Kumar Singh. Welcome everyone to my 19th session. And in this session, we're going to discuss something which is very important. We're going to talk about line chart. So, guys, so far in our discussion in charts, we have discussed different forms of charts, right? We spoke from columnar chart to bar chart to pie chart to whisker plots charts. We have discussed so many forms of charts, right? So one of the very common type of chart is a line chart. I believe you know, right? So one of the chart which we normally use whenever we talk about graphs and diagram is the line chart. So line chart generally, what line chart generally do, it talks about the progress or trend over the time. So we whenever we talk about line chart, probably you can understand the x-axis. What we use is generally the data based upon time. So we keep time as a constant, or we keep the independent axis as a time, and then we see how the value of the other variable changes with respect to the time. So normally in statistics we call this as a chronological classification or time series analysis. The better word would be the time series analysis. So here, whenever we work on line chart, probably if you have understood that the independent variable what we're going to use is the time period. So on that parameter, if I talk in that frame of reference, then you can easily understand that my x-axis will be data type, either time or date time. You can understand that part. So here, if you see Tableau, if I open a Tableau, here if you observe Tableau, so guys, here what I'm going to work on, I'm working on the same data source, Sales Superstore. Okay, so we're going to work on the same data source to talk about the line chart. Now, in order to talk about line chart, you know that one of your variable would be the time period. So if I go to show me, and here if I see, uh, so probably I have three kinds of line chart. I can talk about continuous line chart, or I can talk about discrete line chart, or I can talk about a dual line chart. So, like you can understand, if first let me talk about discrete line chart. So for the line discrete line chart, I need to have one date or zero or more dimension. Okay, so I need minimum one dimension, and that dimension should be based on date time. Okay, that dimension should be a date. Okay, and then probably I need one or more measures. Okay, so here when I talk about measures here, so measures can be either here profit or sales or quantity, discount, anything can be the measure we can use. So let me take uh, so probably if I see here on the basis of dimension, I need one date. So the date, what date I have, order date, and I have ship date. So let me take order date as a dimension, and let me take sales, okay, as a measure, and then I'll click on discrete line diagram. So here I got the discrete line diagram. You can change the axis the way you want. You can change it. Fine. You can change from standard to you can make it entire view. All that you can do. You're most welcome to do that. You can change the color pattern, whichever color you want. You can do that. You can track the sales over levels. Okay, so to get in more understanding, so on 4 year basis, you can see order date. So based on these years, you can see the demand of the order. Okay, how much the sales is made on these years. You can easily make a comparison. Okay, so if you want to make a comparison region wise, you can track the region over here. So in these 4 years, you can see for central, east, south, west, you can easily make a comparison. Okay, this is the sale pattern of the central region. This is the sale pattern of south region. Okay, this is a sale pattern of east region. This kind of as a this if you see this line diagram, it's a straight line. It's a linear relationship which happened. Then if you see the west, this is the relationship. It first went down, then it went up. So you can easily make a comparison region wise. If you want, you can remove regions. Okay, you can make comparison subcategory wise. These are the different subcategories are there. You can make a comparison subcategory wise. If you have too many variables, okay, so you can change the axis. So this also does not make much sense in line diagram. Okay, so these are certain uh, subcategories are there because we have around 17 subcategories, if I'm not wrong. So probably then doing line diagram analysis on them would be little bit difficult. Okay, so in place of subcategory wise, you can do category wise, category wise also you can do the analysis. So you have different categories. You can see furniture, office space, technology. You can see this. This is technology. Okay, so then furniture, office supplies. You can make analysis uh, category wise. Here you made the analysis of sales, right? Of different category. If you want profit also, analysis of profit also, that also you can do. So you can put profit. So you got the analysis of sales and profit of different categories. Now, if you want to merge both of them together, you can click on profit, click on dual axis. So you both sales is there left hand side. This is a primary vertical axis. This is secondary vertical axis, and you can make analysis about them. Okay, so you can do this. Fine. So different measures names. These are the measure names. You can analyze them under these criteria. Okay, so if I put these measures under columns, you can see the same way, same representation in the form of circular representation. Okay, so I just made them to look in circular. This looks much more better, right? So where the red color talks about here, the red color talks about the the profit and sales for the year 2016. You can see 2016 data. Okay, you can see 2016 data, office supply sales. So the this here you can see this values. You can see these values where your green color represent technology. Okay, then blue color represent furniture, and yellow color represent office supplies. Their sales. Okay, their sales for these figure, sales of all of them. This is the profit of them. This is the profit of all of them in these years. This is the profit of them in these years. This is the profit. This red color is the profit data, while this dots, these are sales data of all three products. Technology, you have furniture, you have office supply. So you can do these analysis by yourself. You can figure it out by yourself how to work on this. Okay. So So here, if I take about when I talked about data types and all, we have discussed that if you take order date in column, if you put order date in column, and if you put sales under row, you know that you'll get a line diagram, right? Now, if you want to compare sales and profit of these years, okay, you can put profit also under row, and you can just click on this, go and click on dual axis. So here you can make a comparison between sales and profit for different years. Okay, so this is the one way to put profit here. If you try to put the profit on the primary vertical axis, then on the same axis you'll get both sales and profit. But you can understand this does not make much sense here. So the better it would be better control Z. It would be better if you can put profit in the secondary vertical axis. So you can see here, this is a secondary vertical axis. Now if you put it here, it will make more sense. Or either you do like this, or you just do click here and click on dual axis. Either like this or either like this, you can do, you'll get the same thing. You're getting right. So same parameter you can analyze in different ways. If I put region under color, so you can see this sales figure. This does not looks much sensible for us. So you can see the sales figure. So these are the sales figure for the three products. Okay, then these are the regions. Regions are central, then east, then south, then west. Clear, everyone? So this is mainly a line diagram. By working on line diagram, you can analyze lot of parameters. Whenever we are analyzing, we can analyze different parameters. So in order to work on line diagram, you get a line diagram by default in Tableau when you put date data type in the column and you put measure under row. Either you can do this or either you select two variable. One of the variable can be date, the another variable can be any measure. Go to show me, click on discrete data type. Okay, here you can easily understand those like sum of sales. It is reflecting in green color. So automatically it means it is a continuous data type. While you can see this year order date reflecting in blue color, it shows it is a discrete data type. So discrete data type or dimension both mean same thing. Okay, measures or continuous data type both mean same thing. So all your when I talk about here, so all your you can understand. So all your continuous data whenever we are talking about. So these all measures comes under continuous data. Okay, all your measures comes under continuous data. Your profit, your sales, your quantity, your discount, all comes under continuous data. While discrete data represent what your discrete data is represented by all your dimensions. So whichever dimension I'm talking about, either string or booleans or date time, okay, or geographical, any dimensions I'm talking about, those all represent by the discrete data. While measures measures whenever you drag them under row or column, they will show you the aggregation of the value. They'll show you sum by default. You can change them, all the measures you can change them. If you go here, you go to measure, you can see measure, you can change them to any other mathematical parameter. They always show the aggregation value, all your measures which represent the continuous data, which is represented by green color. While when you see dimensions, they represented by blue color. Okay, they always represent the discrete data. So like if you do analysis here, you can further segregate this. If you just click here, you can further segregate this. The segregation of these 4 years on the basis of quarters. You can see these are discrete data. That's why you can segregate it very easily. You can convert the discrete into continuous or continuous into discrete. So for doing this, okay, so let me just remove it. So, so you can see this. Now I turn this into continuous data. So you can convert them. Now you see both become green color because both become a continuous data. Anyway, we'll speak about them, how you can convert the discrete into continuous data and all. So I hope you have understood whatever we have done so far. You know what are measures, right? What are measures? What are dimensions? So we already in the last class I have spoken about measure names. I have spoken about measure value. We spoke about dimensions. We spoke about different types of data types. Okay, so you have any confusion, do feel to ask questions for the comment option. Let me know if you have any doubt. So what are measures? What are measured value? What are dimensions? Okay, we have already spoken about them. Now, in this session, I have introduced a new angle to look upon dimensions and measures where I'm talking in the term of continuous data and discrete data. So we'll discuss about them in the further class. So thank you everyone. I'll see you all in next class. Take care. Bye everyone.